This is the next section, 9.7, Determinants and Cramer's rule. I want to start this section as this contains the third way to solve a system of equations, which is Cramer's rule, and it'll be an option of what you can do on, and actually determinants are on the final exam as well. So star away. Put this down. All right, talks here about how the determinant of a square matrix is this little formula right here. As long as you have a square matrix. 2 by 2 though. That's the only way you could have it, 2 by 2. Now we're going to practice finding determinants and then how they're applied is like actually later. The symbol for a determinant is unfortunately looks like an absolute value symbol. So if you have an absolute value symbol with like a capital letter, just remember it's determinant and not the absolute value of A. So we're going to do 5 times 2 minus 1 times negative 9. And we get 19. So the determinant is 19. Now there's another way to find, that's the formula for a 2 by 2. When it gets bigger to be like a 3 by 3 or even larger than that, there's a system to do it, which is using minors and cofactors. This is a description of it. I'm going to jump all the way over to the examples to show you how to actually find minors and cofactors and how we apply them to determinants. You do need to know these patterns, okay? This is how to go from minors to cofactors, okay? You keep the same type of number, but you would change the sign if you see negatives. Probably makes no sense to you at all, but we will go with it. Okay, so this is what I'm going to do. I'm first going to pick a row. All right, so or a column, doesn't matter. I'm going to pick row 1. Okay, so I'm going to find all the minors of row 1. That's what we're going to do first, minors. To find minors, you eliminate the row you're talking about and then go through each column and find the determinant of what's left. So to find the minor 1, 1, which means row 1, column 1, I cross them out and ignore them, and now I have a little 2 by 2 matrix of what's left. I use the formula for a 2 by 2 matrix to find the minor. So I would go 3 times 4 minus 2 times 2, which is 8. All right, let me erase all these markings. So now I'm going to do the minor of 1, 2, which means row 1, column 2. Ignore those. Find 2 by 2 of there. 0 times 4 minus negative 4 times 2. So it's 0 plus 8. So that's 8. Then I'm going to do the minor of 1, 3, meaning row 1, column 3. So we're going to do 0 times 2 minus negative 4 times 3, which comes out to be 12. So that's the minors. The cofactors are these same entries except they're different signs. Oh, I should use M's here, just so I change these all to M's. So then cofactor 1, 1 doesn't change because there's a plus sign up in that little box above that pattern. Cofactor 1, 2 is a negative, so I'm going to make my 8 a negative 8. And cofactor 1, 3 doesn't change because there's a positive sign with it. To find the actual determinant from a 3 by 3, we're going to do cofactor times row entry. So our cofactor for 1, 1 was 8. Our entry for 1, 1 is 9, so 8 times 9. We're going to add it to the cofactor 1, 2, which is negative 8, times the entry, which is 3. And then we're going to add the cofactor of 1, 3, which is 12, times the entry, which is negative 1. And this comes out to be 36. So the determinant of that whole matrix is 36. All right, onward we go. Next is basket method. I need a little bit more room. and a skinnier marker. Okay, so I'm going to change this. So basket method, what you do is you're going to repeat the first two columns again. So 9, 0. Let me make this bigger. It'll be easier. So I'm going to write my matrix and then rewrite my first two columns. Okay. And now I'm going to multiply up diagonals together. So -4 times 3, -4 times 3 times -1 is 12. 2 times 2 times 9 is 36. 4 times 0 times 3 is 0. We're going to add these, and you get 48. So far, so good. Then we're going to do the bottom diagonals. So 9 times 3 times 4, which is 108. 3 times 2 times -4, which is -24. -1 times 0 times 0, or times 2 is 0. When you add these up, you get 84. To figure out the determinant then, you do bottom minus top. You should probably write that down for basket. Bottom minus top. So 84 minus 48 is 36. And I hope it's 36 because if you didn't notice, this matrix is the same matrix as the matrix before. So hopefully they still have the same determinant even if they're doing it a different method. Same thing. Again, we have the same matrix, except it says find the determinant row by expanding by the second row and by expanding the third column. Well, we'll just do one of them. I'm not going to do both. We'll just do one of them. We'll do third column though. So I'm not going to do this one. I'm going to do third column, which means I'm using these right here. Okay, so we need to do minors first. So minor of row 1, spot 3. I don't know why I'm writing A. Let me do an M. Row 1, spot 3. Row 1, column 3. So I'm going to ignore, and then do my little 2 by 2. So 0 times 2, -4 times 3 will give me a 12. And then minor row 2, column 3. Row 2, column 3. Here we go. 9 times 2 minus -4 times 3. So 18 plus 12. 18 and 12 is 30. And then minor 3, 3, which means column 3, row 3. So 27 minus 0, 27. I can't use those. I'm supposed to use my cofactors though. The pattern for this one is that, plus minus plus for that bottom column. So for the cofactors, cofactor 1, 3 is a 12, cofactor 2, 3 is a -30, and cofactor 3, 3 is 27. Now to find the determinant, you take the entry and times it by its corresponding cofactor. So 12 times -1 plus -30 times 2 plus 27 times 4, and we still get -30 or positive 36, which we should, I hope, because it is the same matrix. All right, does matrix A have an inverse? It is a square one, right? 4 by 4. We could just put a to the -1 in your calculator and it should say error. It'll tell you it doesn't have an inverse. Okay, moving down. Evaluate the determinant of the matrix. Does matrix A have an inverse? Well, if it has a determinant, then it has an inverse is the rule. And this one is a really big one. So this one you should put in your calculator. So we're going to edit matrix A, make it a 4 by 4. Oops, uh-oh. I want that to be a 4. 4 by 4. Okay. 6, 2, 1, negative 3, 1, 2, 6, 9, 18, 6, 7, negative 9. And then last one, 18, 8, 3, negative 9. Get out of there. So we're going to go back in. This time go over to math. Number one is DET, stands for determinant. Go back in, grab matrix A, hit enter. There you go. Tells you the determinant is just negative 456. No calculations. Your calculator is just spiffy and can tell you those all neat things. So yes, there's an inverse. Now how we can apply these. This next thing is Cramer's rule. All right, Cramer's rule. This is the gist of it. To find your x value, you are going to do the determinant, and you're going to replace the x coefficients with what they equal. So instead of this being an A and a C, the original coefficients, we are replacing it with what the equations actual equal. See, right there. The bottom is just the coefficients of the matrix, A, B, C, D. You find the y value, the numerator, you leave the coefficients of the x and replace the coefficients of the y with what the answer is. And the bottom is just the coefficients of x and y. All right, so I'm going to write these as two matrices. Oh, no, I'm not. Why bother? We'll just go right ahead. Okay, so to find x, it is a fraction. It is two determinants. The determinant on top, instead of writing, since we're finding x, we're going to write the answers and then the coefficients of y as our two columns. So negative 4, negative 1, 10, 4. Then for the bottom is just the coefficients of the original matrix, or coefficients of the original variables. So when we do this, if I do my 2 by 2, negative 4 times 4 minus negative 1 times 10, so we get negative 16 plus 10, negative 6 on top. The bottom, 3 times 4 is 12, 12 minus 10 is 2. This is negative 3. For the y part, it is a fraction. Let me get rid of all my arrows and circle pieces. For my y part for the top. Okay, so I'm going to put the coefficients in for x, but I'm going to put the answers in for the next column, since I'm using it to find y. So 3, 1, negative 4, negative 1. And the bottom stays the same. It doesn't change. It's always the coefficients of the variables. So we know the bottoms too, because I already solved that. Well, the top, 3 times negative 1 is negative 3 plus 4 is 7. Just now what I got on my paper. What did I write wrong? Negative 3. Oh, that would be why. Negative 3 plus 4. Negative 3, yeah, negative 3 plus 4 is 1. So our answer is negative 3, 1/2. Those are the two values. Then it says you can use Cramer's rule to solve a system for a 3 by 4. which is 3 equations, 3 variables. I'm going to just set up what you would type in, and then I'll give you the answers. So for x, instead of the x coefficients, I put in answers. Then I'm going to do my y's, and then my z's. So if you choose to solve the equation on the final exam and using Cramer's rule, you could do it this way. The bottom is just the coefficients. Once you get here with a 3 by 3, you can just pop it in the calculator. This comes out to be negative 12 35ths, 20 thirds. 20 thirds. All right, now to do y. So the numerator, I do coefficients for x, answers for the y part, then coefficients for z. The bottom stays the same. There's a 1 there. And y comes out to be negative 141 over 92. And then z, the last one, so the top I do coefficients for x and y. 0. Answers for z. The bottom's the same as the other two. Oh, this is a negative 4. Yeah, sorry about that. And then 5, 6, 0. And z comes out to be 2/23. And the last way we can use Cramer's rule is actually finding the area of a triangle. If we know the coordinates points of the triangle, we can use this formula here to actually find the area. The plus or minus indicates whether, once you do the determinant, if the determinant comes out to be negative, then you times it by like a negative half. So you get a positive value. If the determinant comes out to be positive, then you times it by positive half. So the determinant, so your area is still positive. Regardless, you want a positive area. So if these are our points, so the area is equal to 1/2 of the determinant, and it goes 0, 2, 1, 3, 5, 1, negative 4, 0, 1. And if I do row 2, say I do row 2 and I'm expanding it by row 2, find the determinant that way. So I'm going to do the minors. So minor, row 2, column 1. So I ignore row 2, column 1. And I'm going to do 2 times 1 minus 0 times 1, which is 2. Minor, oh look, it changed. That's okay. 2, 2. So I do 0, 1, which is 0, minus 4, plus 4. And then minor 2, 3. So I'm doing this one and this one, which is 0, this one and this one, which ends up being 8, because I minus a negative 8. And then we got to do cofactors. The pattern for that middle row is a negative, a positive, a negative. So I'm changing this to a negative 2. This stays at positive 4. This is a negative 8. So I'm doing negative 2 times 3 plus 4 times 5 plus 8, negative 8 times 1. And this comes out to be 6. Negative 6 and 20 is 14. 14. Yep. This comes out to be 6. Well, we're taking half of it. So our area is 3. And that is the end of 9C.